speaker of the day, who is Sushmita Wabale. She will be speaking on module magic, multi-module workspaces to the rescue. She is a senior software engineer and a programmer at Josh Software.
Okay, hello everyone. I hope you can hear me. So I'm here to talk about module magic, the multi-module workspaces to the rescue. So let me introduce myself. My name is Sushmita Wabale. I work as a software engineer for Josh Softwares. I've been working in Golang since 5 years now, and I love to build different kinds of products in Golang. Telling you more about Josh, Josh stands for passion and enthusiasm. We at Josh believe that programming is an art and we are the artists. We also enjoy taking workshops and arranging talks, etc. We are also part of organizing team for GOPHERCON India. And on the business front, we provide tech solutions to the clientele all over the world since 2007. Please follow us on the Twitter if you want to know more. So before taking you to the multi-module workspaces, let's first just revise some of the basic concepts of dependency management. So what is dependency? So dependency is any external library that you are using in your code. We keep on using this library. If they are deprecated sometimes, we have to replace them with the new ones. So all this process takes a lots of time. So the dependency management tool helps us to manage these dependencies more in an efficient way. For example, if you know many popular languages like Node has NPM, Ruby has gem. In the same way, Golang also has Go modules. But when I started working in Golang, before 5 years, there was no dependency management tool in Golang. So there was no Go modules, there was nothing. So whenever we had to use any external dependency in our code, we have to use the command go get and the library name. This used to pull the code from the master branch of that Git repository. So whenever there is any change in the external dependency, your production code has to suffer from it. So this was the triggering point where the Go community started searching for the dependency management tools in Golang. So if we see the journey of dependency management tools, the first tool that they tried to use was vendoring. So talking briefly about vendoring, vendoring introduces a folder in your Go code where all the dependencies are stored statically. So there are some pros and cons of this vendoring. The pros was the build was quite faster because all the static library was available in your code. But there were more cons for this. It was the code base grew very much, it was a large code basis, and we could not use multiple versions of same libraries. Then the Go community started using GoDep since 1.9. The dep was, there was one dependency file which has to maintain all the dependencies. It was kind of like package.json that we have in NPM. The cons of this was you have to download one dep tool externally to use this, and the dep file was not readable. You could not tell what are the direct dependencies that the code is using or what are the indirect dependencies. Then there was introduction of Go modules, which was introduced in 1.11, and it's been the default package manager tool in Go for since 1.13. And then the multi-module workspaces was introduced in Go 1.18. Talking about magic modules. So the Go modules was the first official dependency tool introduced in Golang. It gave the liberty to move out of Go path. So earlier, we have to place all your code in Go/src, that is the Go path. But by the introduction of Go modules, you had the liberty to move out of it and you could place your project anywhere. Then all this was available in one single tool. You did not have to download any external tools like dep. So how actually Go modules manage dependency? It manages dependency in a file structure. There's two important files which manage all this dependency. First is go.mod, where you define all your direct dependency, and then we have go.sum, where we have the particular get version of the code that you're using. So starting with the problem. So a year ago, I started developing an fintech application, which was used for the payments. So this is like a kind of architecture diagram for this. So you can see there's only two services here. That's the auth service and the payment service. I had a database at the backend, and the client communicated with payment service by the API. So first, let me explain you what is dependent module. So I had like two services, auth and payment service. In the payment service, I used auth.authenticate. Authenticate method is from the auth service, and payment service is a different service. If we see the code for auth service, I was using a decode token method that it was just decoding a base 64 token, verifying the token, and returning if the user is authenticated or not. Later, my team, we suggested we move from base 64 encode to the JWT token. So I had to make changes in my code. So I made the changes locally. So how do I test these changes now? As the changes are in my dependent module, I have to test the main module. Do you know how do we test this module? Any guess? Okay, I'll tell you. So we have two approaches to test this module. First is, you can see the go.mod file for the payment service. Here you can see the dependency is taken from the go.mod, that is the Git repository server. We can see the version number. So here, if we add the replace directive, and if we point it to the local service of your code, then you can test the local changes. You must be familiar with this replace directive. It has been quite popularly used. Then we have an approach 2, where you can commit all your dependent module changes to the Git, and then you can go get the same changes with the particular commit show of the commit. So after a year, as my application grew, so there was introduction of many services in my application, like customer service, order service, and client service. So all these services used the authentication service for the authentication purpose. Now, if I had to make the same change that I made from changing to base 64 to JWT, I had to make changes in every go.mod file. That is, I have to modify payment service, customer service, order service, and the callback service. But I'm a lazy person. So here, Bill Gates is talking about a lazy person. So there can be two kinds of lazy person. The wrong kind is he'll avoid all the work and not do any work. But the right kind of lazy person will be very resourceful. He'll come up with the shortcuts to save his time. And I think I'm the right kind of lazy person here. Now, what are the challenges using in Go modules? First case, it was relying on the local replace directive, relying on the unpublished module changes, and what if you commit the replace directive? So if we commit the replace directive and your fellow team member does not have the same path as you have in your directory structure, the code is going to throw some errors, and it's going to cause a lot of hassle to, again, so we generally avoid this committing the replace directive. So what's the solution? So here, I'm trying to replace the replace with the workspaces. So let's introduce workspaces to you. So what is workspace? So workspace is a collection of modules on your disk which acts as a root module. This feature was introduced in 1.18, and I'll take you through a small demo for this. Okay, so this is my actual code base, where you can see the application name is JoshPay. We have different kinds of folder here. Every folder represents a different module. Every folder has its own go.mod file. Here I have an pay API, which is calling an initiate payment handler method. Let's see what's in this method. So this is a simple HTTP request response method. Here I'm using authService.authenticate. This authenticate method has been imported from the auth service. Here in the import statement, you can see I'm importing this from GitHub, Sushmita, Joshpay, auth service. We can see it's been imported. Now, if we want to see what's the actual code in authenticate method, let's drive there. So in the auth service, we'll go to service folder. So as this is my dependent module, you can see the authenticate method now. So in this module, you can see I'm using a base64 decode token method, where I pass the authorization header that I'm getting in the API. And you can also see I'm printing a message that authenticated using a base64 encoded token. Now, let's change this code, and let's just change it to the JWT tokens. Like we use the JWT library for passing the token. Firstly, we get the header from the API. Then we use JWT.pass method. We pass the token string and the signing method that we have used. Then we have a log message like we authenticated using a JWT token. So in this way, I have made the local changes in my code. Now let's try to run the services. Firstly, let's change the directory to the payment service, because here I am intending to run only payment service. So I'll run it using the traditional command that we have, go run main.go. You can see the server is started on 8080. Now I have an API, right, /pay. I'm going to use a call request to test this API. You can see in the header, I have passed a basic base64 encoded token. And now we can see the payment was success, and we got the log message as authenticated using base64 encoded token. But I made the local changes, right? So I don't know why I'm getting this method. So let's again see the go.mod file we have for the payment service. So here we have go.mod file. Here you can see the auth service was imported from the Git, and we can see the version that it is using. So it doesn't reflect my local change. So what I could do is I could use the replace command, right? But no, the whole point of giving this talk is I want to replace the replace. So I am not going to use this approach. So what I'm going to use is I'm going to initialize a workspace in my project so that I don't have to edit this go.mod file. So firstly, what you have to do is you have to change directory, come to the root directory of your folder. So here Joshpay is my root directory. So I'm going to use the command go work init and the module name that I want to add in the workspace. So here I'm going to add go work init, payment service, and the auth service, because I want to test the payment service with new changes, and my new changes are in the auth service. So here you can see, if we list the files, the go.work was the new file that has been created. So now let's see how do we actually run the code now. So we run the code from the root directory itself. We run it using go run and the module name, that is go run payment service. So here you can see the server is again started on 8080. And now I'm going to use the curl request, but now I'm going to use the curl request with the updated authentication token, that is a JWT token instead of a base64 token. Now here you can see the payment was success, and we get the message as authenticated using JWT token. So without modifying the go.mod file, I was able to do this. So you must be thinking this is a very, it's a basic thing, right? But to make the changes in all of the files is a very tedious task. Like in reality, I had 16 microservices, and every time I make changes in any common microservice, I had to make changes in the 16 files. So using Workspace saved a lot of my time. Okay, so let's revise how do we get started with the workspace. First is let's all the directories so you can see all the services. Then we initialize workspace with go work in it and the module which we are going to test. Let's list again the files. Here you can see the go.work file was created. But what exactly this go.work file contains? So let's see that using the cat command. Here you can see there are only 2 lines in the go.work file. That is first the go, the version that is using, that is 1.18. And we have used directive with the module name. Here the module name represents whatever we have initialized in the go work in command. If we have to add more modules to this, we have to use the command go work use and specify all the modules that we want to use. And after doing that, the go.work file seems something like this. Like we can see all the modules that we have initialized in workspace with the use directive. So how does this exactly works? So we have a go.work. So what go.work does is like it manages all the dependent modules that we have specified in the workspace. Let's think it of as a collection of different modules which are managed by a single file go.work. And to use this, we are going to use the command go run module name. This command, we have to use it from the root module rather than the particular service. So how go.work manages dependency? So from the introduction of Go 1.18, there was a work file flag which has been introduced. So whenever you try to run your services and the go.work file is present, this flag is automatically turned on and you'll run all your services in the workspace mode and not the normal mode. Also, there is one more file which helps managing dependency, that is go work sum. So if you have worked with Go modules, so there is a file go.sum which stores all the particular versions of the services we are using. So this is a similar file where go work sum also stores exactly what local changes it is pointing to. So this is like we can test all the local changes with the workspaces, but it is more. Like we can also test the unpublished module. So what is unpublished module? So any module that you have not committed to the GitHub repository is an unpublished module. So let's see how do we test it. So let's take the example of the same architecture we are using. So here I am intending to add one fraud detection service which is not been present or pushed to the GitHub repository. As this is an experimenting service, I am just trying some of the try and error methods to detect some frauds. So firstly, I'll add a fraud detection service. I add a check transaction method. This check transaction method I'm going to use in the payment service. Whenever a payment is success, I'm going to check if this was a suspicious payment or not. So I use fraud detection dot check transaction method that I have defined in the fraud detection service. So let's try to run this. So firstly, we change the directory to the payment service and we run the code using the traditional command, that is go run main.go. But here you get an error that this dependency is not present in your go.mod file. So it also suggests you go get this using this command. So let's go get this. So when we fire the go get command, we get an error that this package is not present on the Git because we have not published it to the Git. We have not pushed our code. So how do we test it without pushing the code? Let's change the directory to the root again. Let's ls. We already have go.work file. Let's add the fraud detection service to the workspace. So here we can see I use the command go work init, payment service, and the fraud detection service, but I do get an error that the go.work is already exists because we cannot have multiple go.work file in a single folder. So the command I use is go work use. I add the fraud detection service to my existing go.work file. So as you can see, this has been added. And now I try to run the service from the root directory, that is go run payment service. And I'm able to run this service without go getting any module. And this is referring to my local change, the local change which I have not published to the Git. So I can experiment with different kinds of modules without pushing it to the Git, and I'll push it whenever I'll have a definite solution for it. So we have some more to the workspaces that we can have. We can switch between the dependency configuration. So what is dependency configuration? Like sometimes you intend to test some of the services with a particular version or the local change, and the some of the services you can still point to the Git. So you can have different dependency configuration. So what Go suggests is, like this, it suggests two approach. Either you have two workspaces, like that is two different folders, and there's some duplication of code involved in it. You have two different folders and two different workspaces. But it also suggests you a different approach where you can directly edit the go.work file and just comment out whatever dependency you are not currently testing. So the best practice is working with go.work. So do you think we should commit go.work file to the Git or not? Why? Yes, that is right, actually. Because like, as you can have different dependency configuration and your peer, like fellow developer could not have the same, so it will cause error in his code. So it's recommended that you do not commit this file to the Git. It is not enforced yet, but it has been in progress. So you have to like remind this and not add this to the git ignore file so that you do not commit this file to the Git. Then when I switched to the workspaces, I was not aware if I get any editor support in this case or not. So it was very amazed to know that VS Code already supports multi-module workspaces. Actually, the workspaces is being inspired from this. And Golang also supports workspaces. It supports highlighting and easy navigations. So let's get to the benefits of workspace. First is this is the cleanest approach. So if we see the history of dependency management and especially the working with multi-module projects, like this is the cleanest approach we can use. Editing every go.mod file is not like an easy job, or like introduction of just one go.work file can make this job very easy. So this is the cleanest approach. This will definitely boost your productivity because you can test all your changes with different dependency configuration and choose the best possible solution. It saves a lot of time because you have to edit all the go.mod file. Then again, before committing it to the Git, you have to again remodify this file that you have modified. So just editing one file obviously saves your time. And this will also boost the open source contribution. So if you have any external like a library or you want to contribute to that, so you can just easily clone it to the local repository, experiment with it, like try your codes, and then you can test it with the workspaces with different configurations and contribute to it. So this was all about workspaces.